Can you see my screen now?
Yes.
Yes. Good. So this is our Group 8 presentation in Advanced Artificial Intelligence Group Study 2. And my name is Yeonhee. And the other members are Che and Siri. We are going to introduce two research papers. So first is a roadmap of agent research and development, and the other is multi-agent learning for engineers. So the first paper is a roadmap of agent research and development written by Jennings, Nicholas, Keisha, and Michael in 1998. We should take note of that it was published in 1998, which is 24 years ago. For the amount of year and still AI field has rapidly been growing and changing. So this paper will be a guidance on key concepts and issues on agent studies in 1990s. It consists of 4 sections: definitions of agents, autonomous agents, multi-agent systems, and application. So agents, according to the paper, an agent is a computer system situated in some environment that is capable of flexible autonomous action in order to meet its design objectives. It is defined in terms of situatedness, flexibility, and autonomy. Situatedness means that an agent embodies in the physical or virtual world and receives sensory input. Next, when an agent is flexible, it is timely response to changes, actively take the initiatives towards a goal, and socially interact with people and artificial agents. The interaction involves cooperation, coordination, and negotiation. Thermostats are responsive to changes in their environments, but do not have the proactive and interaction. So this is the significant difference between agents and thermostats devices. Lastly, an autonomous agent does not carry out an order. It acts on its own without any intervention. So in short, agents are not servants. The field of autonomous agents received attention from the discussion in artificial intelligence, object-oriented programming, and human-computer interface. First, artificial intelligence is the main contributor to the beginning of autonomous agents. This paper provides how ideas in AI planning has been developed since 1970s. AI planning is a subfield of AI where research is what to do. In the early 1970s, strip planning system known as first principles planning is goal-oriented. Once an agent has a goal to achieve, it creates a plan for the goal, executes the plan, and finds a new goal again. In 1980s, however, a new technique called reactive agents appeared because of the limitation of strip planning. Such algorithms is based on calculative rationality, which means that an agent computes what to perform on the basis of its input. It poses risk that its calculation will not be optimal in all possible real-world problems. To complement the challenge in strip planning system, reactive agents were created to be responsive to changes in their environments and make appropriate decisions to that changes. With the failure of reactive agent approach, subsumption architecture emerged and emphasized the interaction between agents and their environments. A subsumption architecture agent has all task accomplishing behaviors and continually maps a condition of situation to corresponding action as a finite state machine does. However, it is difficult for the agent to learn new behaviors and to well perform under non-designated circumstances. This leads to the emergence of hybrid of strip and reactive model in early 1990s. Additionally, practical reasoning agents using folk psychology was developed. Once behavior can be understood by belief, desire, and intention, they update beliefs from their environments and have options on the basis of their desire and decide their action with the intention. For example, a student comes back to her classroom to find her textbook, which is her intention, because she believed that she put the book on her desk yesterday, which is her belief, and desired to read it, which is her desire. The authors mentions that objects themselves are not agents, but it is viable to achieve autonomous agents by object-oriented programming. The main difference between objects and agents is the right to decide. Objects invoke methods, and the methods are executed without the object's decision. On the other hand, agents request actions, and the other agents have the right to accept or refuse the request. Generally, objects are passive, while agents are active and flexible. Microsoft Word provides us with great convenience and help when writing long papers. It only does what we tell to do. However, the field of human-computer interfaces pursues more than this kind of one-way interaction. It studies how computers act like agents, and so that they actively and closely cooperate with humans in achieving tasks. The next part is about multiple agent system, which is also called MAS. It's a network of individual agents aiming at solving problems that are beyond individual capabilities. Thus, in MAS, each agent is considered to be incomplete, decentralized, and computation occurs separately. Its inherently problems lie with distribution of tasks, interaction and communication between agents, final decision-making, and so forth. One of the early models of MAS is actors that are independent and based on synchronous computation. It has been developed to fit in a larger scale of work. Another MAS model that the paper presents is contract net protocol, proposed by Davis and Smith. In the protocol, agents are either managers that give bids when they can perform a task, or contractors that collect bids and give the task to which gives the bids the most. One of the MAS application is air traffic control system. Each flight sets its optimal flight plan to destination. Once a flight is in danger of colliding with another flight, one of them replan their safe routes. The decision of which flight will take the control of the change depends on different criteria, such as more informed agent or more capable agent in that circumstances. So my part is over here.
Can you see my screen, right?
Yes.
Okay. Today I'm discussing about multi-agent interactions, and here we have the three types of multi-agent interactions: is cooperative interactions and self-interested multi-agent interaction, and issue and future direction interactions. So a multi-agent mission MAS has a self-organized system. It is a digitally device made up of several intelligent agents that communicate with one another. Multi-agent structures can tackle problems that are very difficult or impossible to solve with a single agent or monolithic missions. Planning, uh, Sorry. Okay. Oh, planning is a single agent in the process of devising a series of action based solely on their goal capabilities and restrictions imposed by environment. The majority of earlier works focused on related who had a lot of aims to achieve. To put together a cohesive strategy, merchants must have able to recognize, for example, agent protected by may be used to detect and resolve such as interactions. The was dynamically assigned in a line with one of the kind criteria, and self-interested agent interaction. A real-world dialogue take place within the comfort of uncertainty. Have a few benchmarks instead of a single utility measurements, and it's not open, but rather than private, and deal dealers are now not all knowing. Um, the trial has results that shows okay, and the single and issue and future directions in such a open conditions related who had to arrange with one another a face to significant difficulties. First they have should to option to see one another, and and the second they should have to option the between the work, for instance, while handling the construction are more powerful, and against certain disappointment they can likewise manage quickly changing the labor force more rapidly. And here and the applications we are using in AI, so we have industrial applications and commercial applications and entertainment applications and medical purposes. We are using the AI in basically artificial intelligence has been suggested the applications in business and economic to solve certain problems like electricity and computer in common sense. In a science with many applications, it has improved language translation and image recognition, and e-commerce and variety of other sectors. So here we have discussion some of them. And industrial applications, agent science industrial applications were among the first emerging, and today sellers are very in a wide range of industrial systems. And coming to the commercial applications, while modern capacities will generally do expedition complex custom trial designs that serves an extremely limited area of premium businesses applications, especially to those who includes information on the board, uh, will often to be considerably more mass marketing situations. And coming to the entertainment applications, these play a prominent role in computer gamings, interactive theaters, and other digital reality applications, as these structures are frequently filled with semi animated characters that are used in agents. So, and last, medical applications. Medical informatics is a major growth area in computer science, with a new user of computer being discovered every day in the fitness industry. As a result, it should come. It as no surprising the marketers are required in this field. Uh, get to early and applications. So in industrial application, we have multiple. You have using that manufacturing purpose and process control, telecommunication, and air traffic control and transportations. So we are using that particularities. And in industry, okay, the protocol because a manner controls or self continuous reactive system process control is the natural software for realize other agent based system manipulation. And manipulation system has been built for nuclear power plants, monitoring and diagnosis, spaceship and management, local weather management, and metal coil production coil control. Telecommunication structures are huge and disappear networks of interconnected components that requires real-time monitoring and management. And coming to the air traffic control, there are various air traffic management mechanisms is used in this system, which is currently undergoing field trials at the Sydney Airport in Australia. They are monitoring like this by using this as a application. And transport application, there are two types of agent in this situation. One who represents a client who needs or can offer transport, and another who represent the situation stations where the client congrats to be picked up. Okay. Can you see my screen, right? Yeah, okay. Oh, sorry. And next, sorry. Commercial applications they are information management and electronic commerce and business process management. The lack of quality static administration technologies has accelerated what it referred as record overload problems. And information filters, we have two static overloaded problems described here. Every day we have with a massive amounts of data through mails, and for example only a small portion of relevant or useful. So information gathering, we can't find a data to answer specific questions because of the amount of information we have. We want to be able to access the information that matches our needs, even if that information can only be gathered if you get great website so appeal that many initiatives has aimed at achieve it. So uh, in fact the most field for agent applications and electronic commerce. Currently human interaction drives uh, people decided when you buy the things how they are prepared um, to spend and so on. So business process management makes information decision based on combination of judgment and data for several departments, and obtaining relevant, consistent, and up-to-date information across the local businesses. On other hand, in time-consuming and complex procedure. And the entertainment, we have games and interactive theaters and cinemas. So here in games, using the agent principles, and Grand Enclave develop a wide, a popular creature game. A creature offers a rich simulated surroundings containing a variety of artificial retailers that the person can interact with within a real time. So interactive theater and cinemas, by interactive, we mean a system that allows the user to play a role in the a film that are portrayed by actually a human performance, while engaging with the artificial computers characters who have real life behavioral characteristics. A variety of students have been established to study the evolution of such agents. And the medical applications, we have patients monitoring and health device we are using in the collection of professional with drive area of expert collaborating to organize the patient fitness care. And the second most crucial element in is the patient record among the participants of vital care team, and particularly tendency to have a little opportunity screen a patient minute by minute. Reputations that ask one of the other had frequently falls to the nurse who construct frequently a lack of knowledge, and that interpret facts obtained in the way suitable professionals would. Healthcare is incorporated with the resources of several individuals that allows to represent of this process with the agent mapped onto the people and perhaps businesses involved in the healthcare process too. In future directions, there the concept of self-obtaining problems interact with variety of goals is usually software engineers abstracting. On the other hand, planning and constructing agent structures are complex. So in addition, challenges that comes having the flexible and cutting edges interacting with among the self-retailer troubleshooting components. Currently, there are two major technical impediment to widespread adoption of the agent technology: a systematic methodology that allows designers to easily specify and shape their functions as a multi-agent system, and a lack of widely accessible industrial strengths, gadgets, toolkits who need is a systematic capability for analyzing the problems, figuring out how the uh, best structure in the multi-agent system, and figure out how the structure characterize retailers. Human must first establish a faith in the agent before they feel comfortable handing the duties to them. A user must trust, which takes some time. Uh, this is my part.
Hi guys. So I'm going to discuss about my part. So my part is what is it? Multi-aging learning for engineers. So going to introduction. The question was multi-aging learning is the answer. So what is the question? So multi-aging learning is the address this question through the presentation of challenges with the focus of various engineering applications and discussion of the potential appeals to the multi-agent learning meetings and the challenges. It also highlights the various difference in the underlining of the assumptions and issues concern the generally differentiate engineering applications from the models typically consider the economic game theory. So multi-agent learning for engineers we basically use in the game theory. So from an engineering perspective, the primary focus of the multi-agent learning is to assist the design of a complex systems which include the multiple agents. So we kind of, so in this introduction, I'm going to do descriptive agenda, so perspective agenda, so engineering agenda. So why multi-agent learning? So designing an optimal distributed control system is challenging due to going to the limited communication capabilities, quality components, uncertain of host environment, faculty quality components. So these system consists of a collection of disappear interacting components in optimizing global collective objects to local decision making. However, the complication of the task is generally limited by the limited communication capabilities, local and dynamic information faulty components and uncertain, if not a host environment. It is also not feasible to pass all the information to a command center that could process up a disseminate and instructions. So descriptive perspective and engineering. So most multi-agent learning are based on the literature economic game theory. So the literature was not meant to provide method designing for engineering systems, which emphasizes the importance of the understanding the problem. So as a result is the descriptive and perspective roles are critical distinguishing the element of multi-agent learning in the engineering designing. So defining the game, Nash equilibrium, and performance convenience and averages, learning dynamics and bounded rationalities. So continued. So descriptive and perspective and engineering. So depending the game is basic players focus on the reducing of complexity through the repeating games with a more sophisticated structure. So going to be this, sorry. Nash equilibrium. A substantial amount of work on multi-agent learning has been done with the various algorithms whose limiting behaviors and characterized by a significant amount of work of Nash equilibrium, performance and convergence and averages. Learning in the game entirely behaviors characterization of the learning mechanisms in terms of limited equilibrium set, no specific application domains of performance assessment. And the next was, we continue. So limited information and costly communication. The information available for each agent is critical in multi-agent learning. So uncoupled learning limits behavior of learning dynamics and boundary relationality. In this, dynamic and economic literature depends on the real-time processing capability. This is because of descriptive social model focus on the high agents learn games. So, however, engineered system agents, the agents are programmed components giving birth to boundary rationality. So the conclusion is engineering agenda differs from economic game theory agenda. Some important aspects in engineering systems are robustness and dynamic knowledge. So what is the robustness? Is classical sense of control theory, and domain knowledge is a necessary component of system engineering spaces. Multi-agent learning methodologies, on the other hand, are basic or do not take in domain knowledge into account. For perspective agenda, it might be some appropriate. So due to the complexion of the interaction between the multiple decision makers, developing Regina's methods to describe the specification of the multi-agent systems too difficult to understanding, analyzing and simulating the multi-agent system. Possible specification technologies can range from symbolic language to mathematical models. So this is my part. So thank you guys.
Thank you.